Alright, what's up guys? I'm here with the fourth page on homework 4. Here we have, consider the following sets of vector components. So we have an x and a y component for each of these vectors. AX, AY, BX, BY, CX, CY, GX, DY, EX, EY, and FX, FY. These are different A through F than they were in the last question. Alright, so basically, what I want to do is we want to find the components of the resultant vector from each of these additions. So we have some wacky additions that we're going to do here. You find the components of the resultant vector, of course. We say that the total is going to be equal to the sum of the directional components of each of these. That sounds more complicated than it actually is. Let me explain. So A and B, we're looking at A and B. We want to find the total x and the total y. We get this by taking AX plus BX and AY plus BY. So that's all this first part of the question is asking us for. It wants to find the total by taking the components from these vectors that we're adding. So AX is 16, BX is 28, AY is -4, BY is 0. So our total is going to be 16 plus 28 is 44. And -4 plus 0 is -4. So -4 is our total x, positive 44 is total x, and -4 is our total y. Done. That's all you have to do for this. Pretty easy, actually. So B plus C. Let's take our total x's and our total y's and add them up. So B's x component is 28. C's x component is 0. B's y component is 0. C's y component is -12. So we get 28 plus 0 and 0 plus -12. That gives us 28 for our x and -12 for our y. There we go. Total x, total y. Okay. E plus F. Let's look at E plus F. So E, we get our total x and our total y. E's x component is 31 plus F's x component is -12. Our y component, E's y component is 0. F's y component is -19. So that gives us 31 plus -12 is positive 19 as our x component, and then 0 plus -19 will give us -19 as our y component. I'm going to go ahead and circle these. So these are our components, these are our components for x and y. These are our components for this third one. All right, D plus A plus F plus E. So all we got to do again is add up the totals. So we have total in x and we have total in y. D's x component is -7. D's y component is 18. A's x component, if we go back, is 16. Its y component is -4. -4, that's 16. F is -12 and -19. And then we have E, which is going to be positive 31 and 0. All right, so -7 plus -16 is positive 9. Minus -12 is going to be -3. Plus positive 31 is going to be positive 28. Double check my math right there. -7 plus 16 is positive 9. Minus 12 is -3. Plus 31 is 28. Yeah, there we go. And then here we have 18 plus -4 plus -19 plus 0. That's going to be 14. Minus 19 is -5. Plus 0 is -5. So that's -5 for our y component there. All right, next up we have A plus C plus E. Again, pretty easy. We can do A's x component is 16. Its y component is -4. It's C is 0 and -12. 0, that's -12. And then our E is going to be 31 and 0. So that's 31, that's 0. We're going to add these together, of course, to get our totals. 16 plus 0 plus 31 is going to be 47, positive 47. So that's our x component. And then -4 plus -12 is -16. That's our y component. Right, and then the last one is add all of them together. A plus B plus C plus D plus F. E plus F. Okay, so that's 16 and negative 4. That was total x and total y. 16 and negative 4. Our B is 28 and 0. Our C is 0 and negative 12. Our D is negative 7 and 18. Our E is 31 and 0. Our X is negative 12 and negative 19. Alright, so let's go ahead and do this. Just to be safe, I'm going to put this into my calculator instead of doing it in my head. 16 plus 28 plus 0 minus 7 plus 31 minus 12. Oh my god, this cat. My cat keeps meowing so sadly at my door because he wants me to pet him, but I've been petting him in between each of my pages of this video for like 10 minutes, so I don't know. I don't know what he wants. It's never enough for him. Alright, so that's 16 plus... I'm going to double check. 16 plus 28 plus 0 minus 7 plus 31 minus 12. This is 56, yeah. And then over here we have negative 4 plus negative 12 plus 18 plus negative 19. So it's going to be negative 17, I believe. Yeah, negative 17. So 56 and negative 17 are our two components from these. So again, when you add vector components, all you're doing is you're adding the x's and the y's together. That gives you the total x and the total y. So we end up getting this nice spread array from this. Part B of this, rather, asks us, for each of those components found in part A, find the resultant vector's magnitude, angle and magnitude. So if we look at A plus B, back here we got 44 and negative 4. So what that means is our x component is 44, and our y component, oh crap, I drew this a little awkward. Let's do it over here. Our x component is 44, and our y component is negative 4. That means that we can find this distance and this angle pretty easily. And again, this is just the result that we got up here, right? This is the vector that A plus B make together. So we can find the angle and by doing the inverse tangent of these two sides. That'll be the easiest way to do this. I'm going to go ahead and do that now. Tangent is adjacent over, opposite over adjacent, excuse me, so that's going to be tangent to the negative first of 4 over 44. You want to drop your minus signs here. Minus signs just tell you which direction to go. Remember, in geometry, you can't have a negative length line. So 4 over 44 is going to be our thing here. We're going to do inverse tangent of 4 divided by 44, or 1 over 11. Yeah, which is 5.19. So that's 5.19 degrees. And then the magnitude we can find using Pythagorean theorem. Right? We have A and B. We're looking for C. So we can do 44 squared plus 4 squared equals C squared. 44 squared is going to be 1,936. Plus 16 equals C squared. Add 16 to that. We get the square root of 1,952 equals C squared. We end up getting C is about 44.2. So C equals 44.2. Our angle is this. So that's how you do this part. You just look at you make a right triangle out of the two components that we got from the previous part. Okay, so the next one is B plus C. For B plus C, we got 28 and negative 12. So this is going to be and that's 28. That's negative 12. Again, we want to find the distance. We want to find the angle. Angle, again, we can get by doing tangent to the negative first of 12 over 28. Very similar to last time. I'm going to ask my calculator what that is. Inverse tangent 12 over 28. Yeah, that's 23.2 degrees. So that's going to be 23.2 degrees. And then the magnitude, using Pythagorean theorem, of course, we get 28 squared plus 12 squared equals c squared. Again, remember to get rid of your minus signs. 28 squared is 784. 12 squared is 144. So we end up getting 928 equals c squared. Take the square root of both sides of this. And we get 30.5. For the magnitude. E plus F, looking back up here, we have positive 19, negative 19. So that's going to be, and that's positive 19, that's negative 19. We're looking for this direction and this angle again. We can use tangent to the negative first, just like the last couple times of 19 over 19. And that'll do pretty good for us. So we're going to do inverse tangent of 19 divided by 19, or of 1, and I'm fairly certain this is going to be 45. Yeah. So we get exactly 45 degrees. Makes sense, these two sides are equal. And then magnitude is going to be a squared plus b squared equals c squared. So it's going to be 19 squared plus 19 squared equals c squared. 19 squared is going to be a little under 400. It's 361. Plus 361 equals c squared. So we get 722 equals c squared. Square root both sides of this, we get c equals 26.9 for our magnitude there. Oh, sorry, my calculator wasn't in frame. So yeah, magnitude was Pythagorean theorem, right? 19 squared plus 19 squared is 361 plus 361. Take the square root of 722, and we get 26.9. So that's how we find this part. Okay, and then these three are the same as those last couple questions. They're just printed on the other page. So up here we have this one's d plus a plus f plus e. That was 28 and negative 5. Positive 28, negative 5 that we found. So this is going to be positive 28, negative 5. We're looking for this distance, this angle. A plus c plus e, I'm just going to go ahead and put all these over here. 47 and negative 16. So that's 47 and negative 16. That's d, that's theta. I made it so that I showed a lot of negative components for my y's. 56 and negative 17 are going to be our last one. So that's going to be 56, negative 17. We're looking for this distance, we're looking for this angle. Okay, so angle, again, in all these cases we're finding angle by doing tangent to the negative first. Of the opposite side over the adjacent side, the far side over the close side, basically. So that's 5 over 28. That's going to be 16 over 47. And that one's going to be 17 over 56. Let's go ahead and just get all of these out of the way really quick. Inverse tangent. Kitty, I'm sorry. I'm trying to do my job. Inverse tangent of 5 over 28 gives us 10.1 degrees. Doing inverse tangent of 16 over 47 gives us 18.8 degrees. Inverse tangent of 17 divided by 56, 16.9 degrees. Okay, so those are those three. And then to find the magnitude again, we can do this using Pythagorean theorem. In this case, that's 28 squared plus 5 squared equals c squared. Here that's going to be 47 squared plus 16 squared equals c squared. And here this is going to be 56 squared plus 17 squared equals c squared. Again, ignore your minus signs. So let's go ahead and do this math really quick. 28 squared plus 25 is square root of 809. So we can say that c is square root of 809, which comes out to about 28.4. 47 squared plus 16 squared is 2,209 plus 209 plus 256 comes out to the square root of 2,465, which is 49.6. And then for this last one, we have 56 squared. Oopsie, 56 squared plus 17 squared gives us the square root of 3,185 equals c squared. We get c equals 56.4. Let me double check that last one. Sorry, I wrote this number down wrong. It's square root of 3,425. And we get 58.5, excuse me. That makes a little bit more sense. There we go. So that's how you do this page. Actually pretty easy. Now we have three questions left on this last page here. This first one is: a train travels at 60 meters per second to the east with respect to the ground. A businessman on the train runs at 5 meters per second to the west with respect to the train. Find the velocity of the man with respect to the ground. So what this means is we have a train. This question looks harder than it actually is. This train here is moving at 60 meters per second to the east with respect to the ground. We're going to say that the ground is stationary, right? So this is how fast he's moving. So we have a businessman on the train. That's east. This is west. He's moving 5 meters per second to the west with respect to the train. So what that means is relative to the train, right? Him and everything on the train is moving at 60 meters per second on this way, right? They're moving this way. So if he's moving in the train, that means that he's moving at 60 meters per second. He starts moving 5 meters per second to the west. We can really easily find his speed with respect to the ground by saying he has 60 meters per second from the train, and then -5, I'm going to call this direction positive and this direction negative, -5 from him walking, right? So his total speed relative to the ground is plus 55 meters per second to the east. Relative to the ground. Again, when it says respect to the train, what that means is that the train and everything on it's moving at 60, so if you think of the train as being stationary, he's moving at 5 meters per second this way. So what that means is all we have to do is subtract those two vectors. Okay, let's look at our medium question here. We're almost done. Starting at the origin of coordinates, the following displacements are made in the xy plane. 60 millimeters in the plus y direction, 30 millimeters in the minus x direction, 40 millimeters at 150 degrees, and 50 millimeters at 240 degrees. Find the resultant vector either graphically or algebraically. Okay, so I'm not going to draw this to scale. I'm going to do it algebraically. If you want to get a protractor and a straight edge, or a ruler rather, to do this graphically, you totally can. You'll get the same thing. Okay, so we have 4 vectors here. We have this one, we have this one, we have this one, and we have this one. So I'm going to go ahead and add these together. We're going to assume standard coordinate play array. So that's plus, plus, minus, minus, that's x, that's y. Okay, so 60 millimeters in the positive y direction. That means our first vector is just on the y-axis. Oh, I'm going to name these 1, 2, 3, and 4, by the way. So this one I'm going to name 1, this one I'm going to name 2, this one I'm going to name 3, and this one I'm going to name 4. So 1 is 60 going straight up. Then we have 30 millimeters in the negative x direction. So 2 here is going to be 30 millimeters in the negative x direction. Then we have 40 millimeters at 150 degrees. So going from here, 150 degrees is like this. Oh, geez, I drew my picture awkward. Oh, that's really annoying. Sorry. It's okay. It'll be okay, I think. So this is 150 degrees. Or if you want to consider that this is 90, that makes this 60 degrees. That's our third vector. It's got a length of 40 millimeters. And then our last one is 50 millimeters at 240 degrees, which will put it over off the edge of my paper here. It's a little bit awkward, sorry. I should have thought this through a little bit better. So 240 degrees is going to be like 60 going down like this. That's going to be our fourth vector. So if we want to find the resultant vector algebraically, we can do this by adding the x and the y components. So we go 1, I'm just going to draw all 4 of these vectors separately really quick. 1 is 60 straight up. It's got an x and a y component. Our second vector, 2, is 30 millimeters going to the left. It's got an x and a y component. Our 3 was like this. This angle is 150 degrees, which means that from here, we can subtract 90 from this. This angle is 60 degrees. And it's 40. It's got an x and a y component. And then our fourth vector here, it was at 240 degrees, meaning like it's in this quadrant. This is 180, which means that this is going to be also 60 degrees. This is 50 millimeters. Right here. Okay, so here are our 4 vectors, and of course it's got an x and a y component. I want to find the resultant vector. We can do this by looking at the components that these have. So here are our 4 vectors. We can find their components pretty easily. The first one, y, is a straight line on the y-axis. It is going straight up, so its x component is going to be 0, and our y component is going to be 60. This is not an angle, it's only moving in the y direction, so the amount that it's moving in the y direction is 60, and the amount that it's moving in the x direction is 0. Okay. Here, 30 is the same thing. Notice we're not moving in the y direction, so our y component is going to be 0. Our x component here is going to be negative 30 because we're moving to the left. For vector 3, this one's at an angle, so it's going to require a little bit more work, but it's still not going to be so bad. We can find the y and the x components doing the same methods we used earlier. So notice our y component's going up and our x component's going to the left, so we're going to have a positive y and a negative x. We can say that sine and cosine of 60 degrees times 40. The side that touches this is y, so it gets cosine, x gets sine. So putting this into my calculator, we can take the sine of 60 degrees times 40 millimeters, which will give us an x component of negative 34.6. I'm going to round it to the nearest whole number, actually. We'll call that negative 35. And then y, our y component is cosine of 60 times 40, which is going to give us positive 20. And then x and y. For this last one, we have 60. This is going to be a negative x because we're going to the left, and a negative y because we're going down. Do exactly the same thing we did over here. So that's sine of 60 for the opposite side, cosine of 60 for the adjacent side. So x is going to be cosine, y is going to be sine this time. We multiply that by the length of the vector, which is 50. So we get sine of 60 times 50 is 43.3. I'm going to call that 43. it's negative 43. And then x here we have negative x, so it's going to be cosine of 60 degrees times 50, which is 25, and that's going to be negative 25. So now for this, all we have to do is find our resultant using this. So our total x component is going to be 0 plus negative 30 plus negative 35 plus negative 25, and our total y component is going to be 60 plus 0 plus 20 plus negative 43. So we can find the total. Negative 30, negative 65 is going to be negative 90. And here we have positive 80 minus 43, which will be positive 37, right? Yeah, positive 37. So these are our total x and our total y component. And what that means is that from here to here, our y component is 37. Sorry, from here to here, our y component is 37 and our x component is negative 90. So we get 37 and negative 90 like that. And then this is our distance. You could solve this using trig, using to find the direction of the magnitude, find this angle, find this side using using Pythagorean theorem and by using an inverse trig function. I'm going to leave it like this. As long as you find the components, I'll accept this answer in component form. Because you've found the resultant vector mathematically by having its components. Positive 37 for y, negative 90 for x.